Welcome back to our series on calibration. I'm Bob Stern, your host. I'm a senior metrologist at Agilent Technologies, and in this module we're going to examine the concepts related to traceability. So the actual definition of traceability is that it's the property of the result of a measurement or the value of a standard whereby it can be related to International System of Units via National Metrology Institutes through an unbroken chain of comparisons with stated uncertainties. Okay, that's a lot of words, but what it says in plain English is that you have a measurement and you want to be able to relate that back to the most accurate standard by an organization like NIST or NRL. And the part that I've highlighted in yellow, the unbroken chain of comparisons, all with stated uncertainties. When they say stated uncertainties, the definition means ISO GUM. So this is the official definition from international terms for calibration. Let's look at an example in DC volts. In the early 1980s, NIST invented a technique for very, very accurate generation of DC voltage using a Josephson junction, which is the voltage across a semiconductor junction when it's cooled by liquid nitrogen. So just to show you the path of traceability, going down this little list here, you have the calibration system, and then you have the measurement uncertainty on the right. And the main thing I just want to show you is that the first line, the Josephson junction, that is a primary standard. So the one that Agilent has is the exact same accuracy as what NIST officially maintains for the rest of the United States. Or you could go to any number of other national laboratories around the world and they also use the exact same Josephson junction. When you use that to calibrate the Service Test Executive voltmeter cal system, which we use in Agilent, and when you use that to calibrate a Fluke 5720 calibrator, then your accuracy that you can measure other voltmeters for DC, you can see it degrades a little bit. It's not quite as good, obviously. It moves down to 4.2 times 10 to the 6th. And if you then use that system to calibrate for lower performance voltmeters, you can see that it grows from 4.2 times 10 to the minus 6 to 7 times 10 to the minus 6. So what you're seeing there is the traceability path if you were to measure a DC volts using any one of those three systems. Now let me move and show you how it works for microwave measurement, in this case power traceability. So the international standard is a joule or the watt, and NIST in Colorado and other NMIs around the world have national standards. In the case of NIST, they have a microcalorimeter. That is something that they invented. It actually converts RF energy to heat, and it's a very sensitive thermometer. And what they're able to do is have a transfer standard with that, which then laboratories such as Agilent can send in our reference power sensors, and that becomes the reference sensor, which then can be used as a production working standard, and finally that can be used to calibrate your power sensor that you send in. So this is the traceability path for power. So here's a photo of the calorimeter, and thanks very much to Ron Ginley and his section in NIST for providing these figures. So you see here is the calorimeter, and then as these go into this assembly in the gentleman's right hand here, and then this is the water bath, and that is the national standard for power. They then use that to transfer to a standard over here on the right in the picture. And then over on the right is where you can send in your reference standard to be calibrated by NIST. So this gives you an idea as you look through each of those three states of the relative uncertainty. You can see the uncertainty gets larger as you get more steps away from the national standard. Perhaps most important in our traceability discussion is this chart here. The x-axis is, of course, frequency. The y-axis is the actual measurement uncertainty of the efficiency factor of the power sensor. And so as you look at each of these, the lower the line, the better. The yellow line is what you would get. In this case, it's coming from the National Physics Lab. That's the top National Metrology Institute in Britain. That would be very similar to the same one you would get from NIST. And then in our example, if you use a sensor in that bottom line there to calibrate a reference sensor, as we have done here, that is the special option 84, which we perform on our Roseville site in California. So you see the uncertainty associated with that. If you then use that special option 84 calibration to calibrate other sensors, you can see that the resulting uncertainty associated with those is the purple line. So it all depends on how great your need for measurement uncertainty to keep that limited determines really which one of these is most appropriate for use for you. Now, anytime that you get measurement results from an outside calibration company, as part of that, you get a trace report. And what you see here is a list of all the instruments, and then you're also able to see the ID numbers and certificates. So if you wanted to be able to say, okay, show me the exact path back to NIST or one of the other National Metrology Institutes, that certificate number would allow you to begin drilling, and you can go back until you get to, in this case, say a Josephson junction at some point for DC volts. I want to make one other note here, and that is, in my experience, whether or not calibration labs provide you with an actual measurement report, I've yet to see any time where they don't provide a trace report, or said in a positive way, every calibration lab that I've ever seen provides a Cal certificate that has a list of the instruments that were used. And that's really another way that you can do an audit, because if you're thinking earlier on in our first module, we said, think about which specifications are key. That can tell you which performance tests should have been tested. You can look at a trace report like this. For instance, if you had a spectrum analyzer and you wanted to know, was third order intermod, TOI, tested, you could look at the trace report and you would expect to see 2 microwave signal generators. If you only saw one, you would know that that important measurement could not have been made. So this is another way where you might do an audit. If you want to take a look at one of those and you're not sure how to do it, please contact your Agilent support field engineer, and they will help you or put you in contact with someone like me who can guide you through that process. And thank you very much for tuning in and listening to this module on traceability. We hope you've enjoyed it, and I hope to see you again in the next module on standards compliance.